Good morning. So let's get started. First of all, welcome to our first Affinity+VE joint webinar. I'm Melissa Steiner, the Marketing Director for Trelligence, and I am joined today by Michelle Farrell, the European Business Development Manager for IES. I'll start us off by demonstrating how to run VE analyses on a program, and then on a schematic design in Affinity. After that, we'll load the Affinity schematic into VE Gaia, and Michelle will show you the extended analyses that are possible in VE, the IES virtual environment. First, let me give you a brief introduction to the partnership between our companies and the integration in Affinity+VE. And, sorry about that. Let me go back to that previous slide. Our companies recently partnered to create a software solution that would help to shift the starting point for sustainability analysis forward in the project lifecycle. Affinity is the industry leader in architectural programming, early design, and design-to-program compliance analysis. Our software also integrates bidirectionally with Revit and ArchiCAD, as well as SketchUp, to extend the benefits of BIM to the early programming and design phases. IES is the industry leader in sustainable analysis tools with a full suite of products that includes VE Gaia and VE Navigator for LEAD, which are included in Affinity+VE. By integrating the two technologies to create Affinity+VE, we've produced the earliest stage sustainability analysis solution on the market. Now, if you take a look at this slide, you can see that Affinity+VE can run VE analyses on the Affinity program data and the schematic design. Results from the program analyses are used to drive project requirements and make early decisions related to sustainability even before the schematic design is developed. Then analyses of the schematic design can offer even more detailed information, and project teams can update the program or Affinity design as new data is available. Affinity's analysis engine also automatically compares the schematic design to the program requirements and alerts the project team to any discrepancies. This way, project teams can be sure that the sustainability requirements are met before moving into the detailed design in BIM. Seamless integration between Affinity and VE and BIM tools provides a great deal of flexibility to project teams. Both Affinity and VE analyses can be run at any time throughout the project lifecycle, and changes or updates can be made to both the program and design as needed. This is true both in Affinity as well as in Revit and ArchiCAD, meaning that analyzing design to program compliance, including detailed sustainability requirements, has never been easier. Next, I'll demonstrate how to run VE analyses on the program data. To do this, I'll use the Affinity Space Program, questionnaire, and an auto-generated stacks building, as well as a selection of VE analyses that are embedded in Affinity. Now let's take a look at my project file. I've preloaded this project file in Affinity. This is a space program for an office building with 6 departments and over 38,000 square feet. There are several ways to view project data in Affinity, making it a flexible tool for programmers, designers, and even for client presentations. In addition to viewing the program data here, I can also look at it in a report format that can be printed or shared with clients. This and many other reports are available in Affinity and are customizable to include specific data, graphics, and even your company logo. Both the space program and the report can help to highlight any discrepancies between the program and the design once it's developed. Now let's go back to the space program view. These views can be customized to display different columns that contain Affinity properties and requirements. Here we're looking at the space program items, both departments and rooms, and the area factor, total quantity, unit area, total area, and comments for each. I can quickly and easily make changes to the column values by entering them directly in the cells, like this quantity requirement. Notice the changes to the quantity or area of my spaces will automatically recalculate the total area for the program. In the Views pull-down, I can see a list of the custom views that are available. Affinity has several preset views that come out of the box and also allows you to create your own. When I open the view called Space, it will change the columns. In this case, adding a column called Dimensions. which is appropriate since this view is focused on the properties and requirements for the individual spaces. To customize the views, I can right-click any of the column headings and select or deselect the properties or requirements that I want to show. Here I can select the unit area and target. Target is one of the main requirements that Affinity tracks. It shows either the quantity or area of the space that is required in the program, and this will be compared to the actual quantity and sizes of spaces in the design when it's developed. Once the program data is set, we need to input additional details in order to run the VE analyses. We collect this information in a convenient questionnaire that's configured using information and data pulled directly from VE Gaia. The data is then automatically loaded into the Affinity project properties when we submit the questionnaire. The first essential piece of information is the type of building that we are creating. For this project, we'll select Office from the menu list. Again, all of these options that you're seeing are pulled directly from VE. The latitude and longitude of the site will be used to gather weather data and run climate analyses. I'm entering the latitude and longitude for a site near the Chicago O'Hare Airport. I'll enter 35% for the glazing, which can be changed later after we run the analyses. And for now, I can select the brick or block wall as the construction type. For the HVAC type, I'll choose the fan coil system. Note that these selections can be changed at any time throughout the project, and most likely will be after we run the VE analyses. Once we gather temperature data, for instance, we may want to change the construction type. We will also be able to add more requirements like insulation thickness later in the project. For now, let's choose the electricity for the cooling fuel and natural gas for the heating fuel. And then I'll keep 65 for the weekly operating hours. I simply hit Finish and Yes to submit the questionnaire, which will add the data to the program, making it available for analysis in VE. In the upcoming steps, I'll want the option of comparing multiple building designs, so I can add a few scenarios. For now, I'll just add scenario 1 and 2. Currently, we have a program and several key requirements that we added in the questionnaire, but no geometrical data. To make the VE analyses more robust in these initial stages, Affinity can auto-generate a stacked building, which will allow us to compare results on different building forms. For instance, we can compare a tall, thin building against a short, wide building for optimal sustainability. The width of the building is dependent on the floor area that you assign to it, in this case, 6,000 square feet. You can choose to assign the building to a specific scenario which we just set up, or to apply it to all scenarios. In this case, I'll choose scenario 1. In the hierarchy on the left, you can watch as Affinity stacks the building. The Generate Stacking function uses the information in the program to determine the size and number of apartments in the building. Then Affinity adds them to the stories from the ground up until they fill the 6,000 square foot area that I specified. Any overflow moves on to a new story. Here we can see that the current program contains 7 stories worth of apartments in a building with a footprint of 6,000 square feet. To compare this with a taller, thinner building, I could rerun the Generate Stacking script with 4,000 square feet per story and assign it to scenario 2. For now, we'll just proceed with the analysis. Let's see what this looks like in the story view. Here in Story 1, we can see the admin services and a portion of the HR department with a filler area to make up the remaining 6,000 square feet. We can also view the building in a stacking diagram, which is one of the view options. Here we can see the building is evenly stacked with departments on each floor. In this view, the building can also be restacked by dragging and dropping departments between the different stories. To get a better idea of what the building looks like, we can also view it in 3D. The 3D view is available in the View drop-down. You can see the colors of the departments in this view as well. So here we can see it's a simple rectangular stacked building, but this will give us enough geometrical information to be able to run VE analyses. Now we have a program that contains additional data specific to VE, as well as a stacked building that contains the departments in our program, which means we are ready to move forward with the VE analyses. A selection of VE Gaia analyses are embedded within Affinity, so we can run them directly without having to open the VE desktop. First, let's take a look at the climate review. This analysis helps you to understand the climate for which you are designing, information about what direction the wind blows, the coldest and warmest months of the year, and other general weather data. The results of this analysis can be used to drive decisions on things like the type of construction materials that you want to use. It can actually be run with just longitude and latitude to get a quick idea of the environment before finalizing the program. Climate review provides early direction in terms of what is most important about the climate for the design development. For instance, in this example, winter is the most dominant season, which means that any building in this location will require heating. As a result, one sustainability consideration would be how to minimize heating energy, which it says here in red. Let's take a closer look at this middle chart, which is based on the Mahoney Analysis. The Mahoney Analysis is a stress test that shows human comfort levels. There are several charts and graphs available in this analysis, mostly statistical charts based on temperature. These types of graphs are useful, especially when working in areas that are unfamiliar to your firm. It helps to give project teams a feel for the area and can help demonstrate to potential clients during the bidding process that you understand the climate and comfort requirements for the residents. Now let's return to the full analysis and take a look at the third graph. This graph depicts temperature distribution, which makes it easy to see which temperature ranges are the most prevalent. The results of this analysis are used in subsequent VE analyses, and the information is used to guide requirements for the building. For instance, we may want to specify that the design needs to contain more transparent surfaces to allow heat in. I can set this as a requirement for the building in the Affinity program. In this final section on solar energy at the bottom of my report, I can see how much usable energy is available and whether or not solar panels would be a useful investment to help offset costs and increase energy efficiency, for instance. Now let's take a look at the building review. This analysis is based on the building type, its form, location, and more. Remember that we entered the building type in the questionnaire earlier. The building review runs the Apache thermal analysis that calculates skin load, geometry, and lead analyses. The building review is a good example of an analysis that combines multiple detailed and complex calculations that are difficult and too tedious to perform manually. One of the major benefits of both Affinity and VE is the automation of highly complex processes like this one. By using our joint solution, Affinity+VE, firms save a great deal of time and effort and benefit from easy access to analyses that are sometimes out of the question for other companies that rely on manual processes. Now let's turn to the full analyses to take a closer look at different sections. The building form section points to another complex calculation, the number of spaces within 25 feet of a window. This calculation reflects the amount of natural and cross ventilation that's available in the building and is applicable to LEED credits. Research has found that up to 20% of heating or cooling loads can be saved by moving rooms around. Using Affinity+VE, we can analyze the building, and if the location has a hotter climate, for example, we can create a department-level program requirement to make sure that the high heat gain areas avoid direct sunlight. For instance, we could create a requirement in Affinity that says IT departments must be on the north or south side of the building. By using these analyses to specify properties for the building and departments, project teams can use the requirements to guide the design, ensuring optimal sustainability. Finally, I'll open the Energy Index. This is also called VE WearSim in our tab. This analysis provides energy consumption and carbon emission predictions, which helps project teams to start thinking about facade design and whether a mixed-mode hybrid system would be advisable, for instance. As the design progresses, you can give VE more information that will feed more specific data. At this stage, we could test and quickly compare different design scenarios to optimize the energy performance of the building. So, just to recap, the process of analyzing the program using VE starts with collecting the program data in Affinity. In my example, that information was already loaded into my project file. Then we run the questionnaire to collect additional data that VE needs to run analyses, like longitude, latitude, and building type, and the information automatically loads into Affinity when it's submitted. With the program and VE data entered, we can generate the stacked building to provide some geometry for VE to analyze. The generate stacking script can also be rerun with different story areas to create a variety of tall or short buildings that can be compared using the Affinity scenarios. Then we run the VE analyses, climate review, building review, and energy index to get initial information about the sustainability of our building. One major benefit to early program analysis is that it helps to set sustainability as a priority for the project from the very beginning. When sustainability analyses are run at the program level, we're able to use the results to drive our requirements. So they're built into the program and become part of the data that Affinity automatically tracks and manages, making it much easier for project teams to ensure that the requirements are being met as the project progresses into the schematic and detailed design phases. Next, I'll run the VE analyses based on a schematic design in Affinity. The design offers more detail on the building form as compared to the stacked building that we used in the previous model. This also allows for manipulation of rooms and even room objects like equipment. So let's open my Affinity project file. This project file is going to include a building design that we'll review in a second. But first, I'd like to take a look at the building properties. Give me one moment as I pull this into the screen. As I'm dragging this over, the properties can be changed at any time to improve upon the initial analyses. And as this opens up, you'll be able to see that all of the building properties that we collected in the questionnaire are now part of the properties for the building, along with a number of other properties that we had previously set. If we scroll down to the bottom, you can see some of the properties that we input in the questionnaire, like percent glazing. So as I mentioned before, we can change these at any time to improve upon initial analyses. So for instance, in the last section, we learned that winter is a predominant season in this location. In this case, we might want to decrease the percent glazing to allow in more light and heat into the building. And here we can change that to 25%. Now we can take a look at story 1. You'll be able to see in this story that unlike in the stacked building that we auto-generated, this design shows the room level, and even some details like furniture and objects can be added here as well. To create a design in Affinity, I simply drag and drop items from the space program list into the story view. When I bring the rooms in, they are the correct size and shape, and even reflect color coding that I assigned in the program. Next to each of the spaces in the left hierarchy, there's a number. These are what we refer to as counters in Affinity. They give us a quick way of understanding whether we are meeting the area or target requirements that we set in the program, and these can be area or quantity. For example, next to the copy fax room, there's a counter of -1. This means that I need to add one more copy fax room to the design to meet the program requirement. As I add the space, you'll see that the counter changes to 0, telling me that my requirement is met. I can also add this on top of an existing space, and Affinity will recalculate the area of the room underneath. Notice that the open plan area measures 1,044 square feet, and as I place the copy fax room on top of it, Affinity will recalculate that area to read 990 square feet. Affinity automates a number of calculations and analyses throughout the program and early design of the building, to make it easier for project teams to quickly and easily manage information and ensure the project and program requirements are met. These are just a few of the examples of what's possible. Now we can also view this design in 3D. This time the model is a full building with a design rather than the simple rectangle that we saw earlier when I auto-generated stacked building. With the building design in place, I can rerun any of the analyses that we did in the previous example to look for changes now that the building form has more detail. But for now, I'll go ahead and just run the ASHRAE loads analysis. ASHRAE allows me to understand the heating and cooling loads for the building and individual rooms using the ASHRAE 2005 heat balance method. There is a section in this report that allows us to focus in on the room level. It's actually interactive and allows us to set a target criteria and view any of the exceptions room by room. The number of my windows open here, it's taking a bit of time to open this up, so let's actually come back to this section. This is usually a bit quicker, so we'll come back to the ASHRAE loads report in the next section, and I can show you the room details at the bottom. For now, let's go ahead and kind of recap this section, and then we can go into launching VE. So the schematic design analysis, as you can see, is quite simple and easy to do. Once the design is in place, we simply run VE analyses from directly within Affinity with a single click. For a more robust analysis, you can use the scenarios to run a variety of design options and continue to compare the sustainability analyses between the different building forms. The analyses that we have embedded into Affinity are only the start of the available analyses within VE Gaia. At this stage, we can make changes to the program or design and rerun the analyses, or we can launch VE directly from within Affinity for more detailed analysis. Loading the model into VE will carry across not only the model itself, but also the program information related to the buildings, apartments, and individual spaces. Now I'll hand the controls over to Michelle, who's going to walk us through VE and analyses like natural resources, daylighting, and materials, which can be especially important for LEED certification.
Okay, great. Thank you for setting this up. You can see that the model has been imported into the VE software. This is actually a separate program, though some pieces of it do sit inside of Affinity and can work without the VE in the background. You can actually bring it out into this analysis software. So I'm just going to go to an axonometric view. And you can see that there's some glazing on the model. And I'm just going to open the three-dimensional view of this. And you can see that the percentage glazing that we have applied to our model has been set on the center of the exterior walls. So this is a very quick way in Affinity and with IES to say, let me test 25% glazing, 30% glazing. Again, it's all about that quick iterative design when we're working at the early stages, and even when the design is developing. So I'm just going to close out this three-dimensional view. One of the things you'll also notice, if you have worked with other 3D models before, whether it's GBXML or other types of analysis software that does building performance, you'll see that there isn't as much of a problem with the transfer of geometry between Affinity and IES as there is with some other programs, because with the larger programs, sometimes it gets a little messy and a little bit complex. Okay, so we're going to look at VE Gaia. There's really two sections in the virtual environment. There are the individual modules themselves, which have been used for over 16 years by engineers all over the world. And then there's these special navigators that we have. VE Gaia is something that we developed specifically for architects and designers to get early feedback and to be part of that iterative design process. We want it to be quick. We want it to be used during your design because the biggest impacts on energy can often be seen at the earliest stages of design. And some of the tools that you'll see underneath here are actually available inside of Affinity. So some of the things that we looked at with climate or building metrics and then also with the building heating and cooling loads. We also were able to compare our building in Affinity against the 2030 challenge, which is looking at different reduction levels depending on what year you're doing that analysis in. So there's quite a bit of features inside of the tool. But the difference when you move inside of the full virtual environment is that you can start customizing parameters about your building. So where you may have picked something like a brick block wall, you may want to start editing that. Other things that you can edit are the orientation of your building. So if I want to see what happens when I rotate my building by 15 degrees, what effect does that have on my analysis, or 30 degrees? So I'm always able to go in and make these changes and take that model a little bit further, but I've already done the majority of my geometry building inside of Affinity. Okay, so I can drop down to Gaia. Gaia, again, is the suite for designers, but I'm also going to scroll down and show you some of the other specialized tools that we have that you can use on your Affinity model. You'll see under rating systems, we have rating systems for different programs all over the world. And in the United States, of course, LEED is probably the most popular that you've heard of, and also sometimes BREEAM, as well as the 2030 challenge. So that it's going to compare your building's energy use against a survey of buildings of its type. So that's what these are looking at. So we're going to take a look today at the LEED Navigator, which will look at daylighting in this case, and some of the Gaia features. But again, we're only going to touch on a very small portion of what's available, because this webinar would just take too long if we covered a lot of things. So I do encourage you to download the trial of this and certainly contact us at the email addresses that you'll see at the end of this presentation for information on how to go through this trial. Okay, so for the first one I'm going to pull up is going to be natural resources. And what natural resources is going to do, and I'm just going to pull up this, it's going to give me the ability to see if I had an analysis to run based on the inputs that I have set inside of Affinity, meaning that this is an office building. And when I assign office, there's other things that are assigned, like there are this many people per square foot. My occupancy is taken into account there. It takes into account the hours of operation. It's going to take into account the heating and cooling set points. And to make this part of your iterative design process, we want to do that automatically for you. Of course, you can always come in here and take that further. If your building is open a certain number of hours and you want to specify that, you certainly can. When you're just looking at building form, you really don't need to go into that detail, because you want to compare apples against apples and say, okay, I have the same baseline settings, but then I'm running a comparison based on that. So here we have natural resources. We have a rainwater collection area. So we had 6,000 square feet per floor, which of course our upper floor is going to be a little bit less because it's using the remainder of our spaces. So I'm going to assume we have this amount of space to collect on rainwater, and I'm just going to hit OK. It's also going to ask me, do I want to apply this to a rating system? This doesn't mean that it has to be with that rating system, but it gives you a metric for comparison. And since I've already run an analysis, meaning previously before the session started, I ran my dynamic thermal simulation, which actually runs at every 10-minute time set to look at the analysis of this building. So when I open this up inside of natural resources, I can see a lot of information about how much my building is consuming. And again, at this early stage, it may not be that you know that this is going to be exactly what your building is going to consume in the end. But you are still able to compare 6,000 square feet per floor versus 5,000 versus 10 stories compared to 6 stories, so different types of plans and layouts. Or in this case, where you have a developed design, you're going to be able to compare that against other schematic designs that you may have come up with the design team. So here we're looking again at the energy consumption in the background. And for the top one, we're looking at photovoltaic resources. So the solar resource that's available, and then saying if we had, in this case, it's going to pick a PV type for you. So in this case, we have this type of solar panel, and we have a certain area. In this case, we have about a 10,000 square foot PV array. So this is quite large, of course. But for this climate, we start to look at and see, all right, based on our building consumption, this is how much we could offset that consumption with this size of PV array. And this is a very large PV array. So we may decide that this option for the site may not be the best option. The other thing we look at is the annual wind resource, and that's what's shown in the blue here. And in the background, again, is our annual electrical consumption. Then it shows what wind turbine was chosen and how that would compare as well. So if we have the same budget to spend on both of these options, we could see that a wind turbine would be more effective at reducing our electrical consumption. And finally, we have our rainfall, where we specified our collection area. We can see how much that's being offset by the annual rainfall, but also not just annual rainfall, but in relation to our exact building use and a coefficient. So what type of roof did we specify in here? In this case, it's looking at it for you. When we go into a later type of analysis, I'm just going to check down to my low and zero carbon technologies and open this up. I can then run the same analysis, but then start to specify with more detail. So I'll say that I know we can afford 2,000 square feet of polycrystalline solar panels versus 2 of these type of wind turbines of 5-meter diameter. So this gives me the ability to look for suggestions at first, but then further in design really compare specific technologies. So I'll just cancel out of this. So now I'm going to move into the daylighting option. And we have daylighting under both Gaia and also under our rating system. So let's open one of the rating systems for interest here. So the first thing I do is select my rating system. We have the most current versions for new construction and major renovations, core and shell, and schools. And we'll always have the preceding version. So that if you've started a project in one of the older versions, you can always take that further inside of IES, and you won't have to worry about adjusting things. I also can edit the spaces in my analysis. This is where it's very important that my room names came through from Affinity, because I want to know which spaces are regularly occupied and which spaces are not. For example, I don't have to have my hallways or corridors as part of my analysis, but the regularly occupied spaces, like my executive suites, will need to be part of this, so I'll just check those off. I can also come in and edit the visible transmittance of my glazing. So I'll pull up some of my glaze constructions. And right here is the one that's being used, but I have the ability to load in different types of glazing from our library, or to just edit the visible transmittance here if I want. I can also edit, if I want to take it further, my wall construction. So I may want to test what happens if I have, for example, my insulation. What if I take that from 2 inches to 3 inches? Because many times you'll find that insulating the building more is more effective at reducing the energy consumption than adding a large PV array. So it's really about comparing all of these technologies and even just making the building more insulated and seeing what is the best way to improve your building design. So I'm going to go into choose simple or advanced and penetrate. One of them has light penetration, which just means if you have interior glazing, you want to make sure that light is going to penetrate through the exterior all the way to the interior, but in this case we don't. So I'm just going to hit OK. And this is actually going to run through a yearly simulation, which again has been pre-run, so that will take a little bit longer, depending on the spaces and the complexity. And in this case we fail, which is kind of expected. We haven't necessarily optimized our glazing, but that's something we can do inside of IES, of course. But we're just looking for preliminary layouts at this point. So you could go back into Affinity, try 30%, try 35%, and start to see what happens very quickly. Here we have every run that we've done previously. We also include the credits, so 75% of spaces pass, and then also the innovation and design credits. And then we have every single floor that we've done. And everyone that's regularly occupied is part of our analysis here. So you can go through and then pull these images out if you need to use them. It also tells our information on the location and the stuff that you're going to need for submission. So once I've completed this, I can check it off. I can also open my information here to show who completed this step and when they completed it. I also have the option to add notes. So I need to say tried, let's say 80%, visible transmittance, and then we could go back and try something different. So it's always good to be able to add notes, so for whoever you're working on the project with can go back and make those adjustments. And then for our final element that we're going to look at is back in Gaia. But again, all of these tools offer this quick iterative feedback that will help you with your design. So going into materials, again, I have the option to change my glazing, change my opaque constructions like my walls or my roof or these other details, ground varying surfaces, which means that if I have a portion of the wall that is above ground and below ground, I can set that all up. But again, with early stage design, I want to encourage architects and designers not to worry about being too consumed with the details. You're just comparing the big picture and saying this is 5% or 10% better than another option. Okay, so I'm going to simulate this out, and I'm just going to say that I've completed these steps. I can minimize this again to give myself more room, and I'll simulate this. Okay, one of the great things that we can see inside of materials is it'll tell us both weight and volume of every material that's used in the building. And when I open the core of these walls, that is where you are able to see, okay, there was brick, there was mineral fiber slab, there were these different elements in my wall. And all of that is now taken account for because we know even the smallest detail down to the density of the material. So we can do a takeoff of your building design, and we'll say, okay, so brickwork, this type of brick, the inner leaf was this much volume of the building and this much in weight, and then the outer leaf was this much weight. So if anyone has ever worked on a LEED project, you know the detail that you have to go to when you look at recycled material and the weight and the volume, and it's often a heavy calculation to do, but if you fill this out correctly, then you can use all these takeoffs right from this list. The other thing it gives you are tips. So if your largest material is brick, this would probably be the one that you want to attack if you're looking at reducing or using more recycled content. So here we're going to say use reclaimed or local sources and try to avoid remotely sourced. Same with concrete. Hollow elements, recycled content, or precast is a good idea, and try to avoid these. So it's just giving you the heads up, as many architects are responsible for specifying this material, of different ideas that you could use in this case for this particular building. And on the right, we're always going to be able to see tips or tricks about what we could do to improve our design. So, for example, one of these comments is, additionally, some materials contain and or manufactured using substances which are toxic. PVC is an often quoted example. So it's just giving you the heads up that, all right, maybe this isn't on this list, but this could be something I was planning on using on a floor or on some of the casework in the building, and I want to try to avoid that here as well if I'm trying to look at a whole green building. Okay, so I'm going to hand it back to Melissa to wrap up the session. And again, feel free to pass any questions through the chat window, and we'll do these at the end.
Great. Thank you so much, Michelle. Okay, let me back. Okay. So, as we've seen, Affinity+VE starts at the earliest stages with just the project program available. We can use the questionnaire to collect important information for VE analysis, which automatically loads into the Affinity properties. By generating a stacked building, we provide VE with some geometry at the early stage for more robust analysis. And then, with the program and stacked building in place, we can run climate review, building review, and energy index analyses to get some initial feedback about our program and the basic rectangular stacked building. The results then help to drive our additional program requirements or change those that we've set up earlier. We use the program requirements to guide our schematic design. And in the Affinity schematic design, we can run multiple scenarios of the building for comparison purposes to find the most optimal building form and adjust any project properties prior to moving into the detailed design. We can also rerun previous analyses like the ASHRAE loads, which gives us information on specific rooms. And finally, we can launch VE Gaia directly from within Affinity for more detailed analysis like daylighting. Ultimately, Affinity+VE enables project teams to shift the sustainability analysis to the early stages of the building project, allowing you to include sustainability requirements in the project program and guide the design toward optimal sustainability. Affinity+VE integrates and automates these key processes, making it very easy for firms to ensure that the design meets the program and sustainability requirements as the design progresses, which also avoids costly rework that's otherwise common with later stage analysis when these specifications aren't considered from the start. As Michelle mentioned earlier, there's a wealth of data and functionality within each of our software tools, and it's impossible to cover everything in a single webinar session, so we do encourage you to get a trial copy of Affinity and VE so you can experience the benefits of the software firsthand. I will include our contact information on the last slide, and you can go ahead and just email us, and we will be able to get you a copy of the trial. Now, let's move on and review some of your questions. Okay, so one of the questions that I have here is, can you run these analyses multiple times? Yes, and that's something that I've mentioned from a couple times, but we haven't shown. What you can actually do is run these analyses, make changes to the program requirements within Affinity, make changes to the design and the schematic design, and then go ahead and rerun these analyses to see where you're at. Like I mentioned, we can also create a number of different scenarios, which helps you to run the analyses based on a couple of different building designs as well. But the nice thing about Affinity is, and IES is that you can actually be very flexible in terms of how you approach these projects. So this is really giving you an environment in which you can run a number of different scenarios and designs very quickly and easily, run analyses, go back, change requirements, run more analyses. So it's very flexible, even though we present it in more of a, A to Z sort of approach for webinar purposes. You can go back and forth at any time.
Yeah, I would also add to that is if you're working with a model, if you export your model again from Affinity and you've done some changes inside of IES, we actually have a tool that's called Model Merge, and that will apply whatever custom settings you've done to the re-imported building. So that's a good option as well. So it's entirely flexible and really made to fit inside of that option.
Yeah, perfect. That is something that's very similar between Affinity and VE is the flexibility. So that's definitely a huge benefit in terms of combining our software.
And the next question that I see as well is talk about how the program will be supported over time. Standard changes, LEED version 3, for example, will be out fairly soon. Exactly. We are constantly updating this, and our tool is going to remain current with all standards. That means maybe we're talking a couple days after it comes out, but we work directly with the US GBC and other GBC organizations around the world to make sure that we have these updated standards and we're up to date with everything. So we're always changing it. A large part of our business in the US is mechanical engineers who do the 90.1 2007 ASHRAE analysis for the energy side of LEED. So we cannot even miss by a couple days. We have to be there with all the latest versions. And that's something that IES is very dedicated to doing.
Perfect. Okay, I have one more here asking about whether you can adjust different parameters, for example, for wall construction on existing Affinity designs. Again, pointing to kind of the flexibility within Affinity, all of the properties and parameters that you see, especially when we opened up the building section, we have a kind of list of all of the properties where I showed you where the questionnaire loaded properties into Affinity. All of those are customizable, including actually the types of properties that you're seeing. So not just the values that you input, you can change those at any time and again run those analyses again, but you can actually customize what properties and parameters are located within Affinity as well. So if you have some custom items that you want to put in there, then you can definitely do that using our Affinity templates and whatnot. So again, this is pointing to there's a lot of functionality that's left to be explored within both Affinity and VE, and definitely within the integration between the two. So.
Yeah, and I would add to that is that at the earliest stages of analysis, you're basically going to say, I know this is a brick block wall that has an approximate R value of this. And to compare just, different stacked buildings, that's often fine because you don't even have the rooms laid out in the way that you want. But later in the project where you move to design development, which was the second model Melissa was showing, then you're going to know exactly what your building square footage is per floor, where the rooms are placed. That's when you want to worry about coming into the virtual environment and saying, okay, I know I have 3 inches of rigid insulation, and I want to test what happens when I put it in the core of the wall versus the outside face of the wall. And you can go that detailed. And so part of it would be the first step where we're doing just schematic. We would go in through Affinity. We would use the basic settings. We would run an analysis and make changes. Then later, we would take the information. If we re-exported something from Affinity, we could then use model merge to say, I created some custom constructions inside of VE. I want them applied to my new model. So it's very quick to do. It's just, where are you creating the data? Where do you want to do it? How detailed are you getting with your analysis? And it's really usually for architects, it's about the stage that you're at with design.
Perfect. Okay. Do you have other questions on your end, Michelle?
Okay. Yep, I have a couple here. It says, when will IES and Affinity be available in the UK? If you are from the UK, I'm actually already in Europe, so the actual IES is the #1 analysis software in the UK right now for engineers. We do a lot of work with Part L, with the standards that you have to reach with BREEAM, which is, of course, much more important for people in the UK than LEED is. So it is currently available now, like today, and was available much longer in the UK than it has been in the United States. And that's where our headquarters is. The other one that I'm looking at will incorporate ASHRAE 189.1 green build design. It's right now because our software is related to being approved by ASHRAE 140, which is the test for analysis programs. We can be used for any of the ASHRAE codes. So yes, you could manually do that through the software if you're an engineer. The reason I say if you're an engineer, because if you're an architect, it might be a little bit harder for you to do, but you certainly could do it. I'm an architect and I know how to do a lot of this stuff. But what we've created are specialized navigators. So if you're an engineer and you work with 90.1 design, which 90.1 2007, you know that when you set up your different HVAC systems and you set up your different options, you have to apply very specifics to that. So we created a more automated way of doing it. So it is possible to do that through it, but it has to be kind of it's more manual than our navigators. But that being said, it's probably something that we'll do in the future. And as we're just adding these different navigators from around the world.
Perfect. I have a couple more here, but some of these are more tailored to their specific projects, so I'll go ahead and email you directly. Do you have anything else popping up on your side before we log off?
Okay, no, I think it was just a couple of really overview things. Of course, the design changes, which we spoke about, it's really flexible to go back and forth. Does IES work with Revit? Yes, both Affinity and IES work with Revit. So if you're bringing it from Affinity to Revit, then IES, or Affinity to IES, or Affinity resizing a Revit model back to Affinity to IES, all these things are possible. And you can look on our website for information about our Revit plugin. The other question I had was, do you have to buy the whole group of modules? You don't. You can also buy things that are just daylighting, for example, if you're only working on doing that portion of it. If you're not an architect and you don't want early stage tools, you just want to do electrical, lighting design, you can certainly do that as well. And it's really based on specific packages. So you have the early portions that can come as part of VE Gaia and what you're going to get inside of Trelligence Affinity. And then you could say, all right, well, I also want to offer daylighting in my office. So you could say, I want to add one more small piece of IES. So it's completely customizable to the needs of your firms, as the needs vary so greatly in the services that you offer. But I would encourage people that are doing this, especially designers, that for some of the lead credits you have to fulfill, if you're doing these 3D models with Affinity, with Revit, you have the ability to not outsource some of that and actually do that in-house. So take advantage of the models that you're doing. And I think that wraps up the questions I have, Melissa.
Okay. I actually see a couple more that just popped up. Someone's asking about, okay, so you just touched on the connection between ArchiCAD and Revit. I have a question about net versus gross square foot. We can incorporate both of those. There was someone asking about whether they saw that net square footage was in the reports. Again, our reports are completely customizable. We have a number of different properties. Those were just showing very specific properties. So yes, you can have net and gross square footage reflected in those. I also have a question about videos for the trial version. We do have videos online. I know you at IES have just redone your website. Are your videos available on there as well?
Yeah, you can go and check out, if you can get on at work, YouTube/IES+VE, just like down in the bottom right-hand corner of your screen.
Okay.
You can go to our website as well. We have lots of information, lots of resources, all about just figure out, are you going in the section of being an architect, a designer, an engineer, and if all else fails, directly just email sales, because everyone has a very custom package, and the pricing can vary so much, and it's really worth just going in and saying, this is what we do, what should I have? And that's a very quick way to do it, instead of if you get frustrated picking up all the different pieces of it.
Yeah, we do a lot of those as well. If you have any questions, we have Affinity for Affinity Desktop, Affinity+VE. We have Affinity for Revit and Affinity for ArchiCAD. So there's a couple different versions, and you can definitely just give us a call, let us know what you're working on, and we can kind of customize something for you. We do have videos on our website. I believe actually we have a very brief overview of Affinity+VE that the link should be on the homepage. We also have a YouTube channel as well, but I believe all of our videos are the same on our website and YouTube. The overview video is a really good way of kind of getting the broad concept of Affinity+VE, and it might be good for if you have any of your colleagues who couldn't make it here today. Obviously, we'll have this recording available, but if you want to just kind of introduce the idea to some of your project team members and see what they think, then you can go ahead and run that. It's like a 10-minute video, so you can just kind of give them a general idea of what we're working with. And I think that wraps up the questions. There are, like I said, a couple more that are a little more specific, so we'll go ahead and address those via email. So that's it. I think at this point you can take a look at our email addresses here on the bottom. Feel free to contact either us or Michelle at IES. They're both sales@trelligence.com and sales@iesve.com, and that's a good way of reaching us to set up the trial version of both the softwares. And like I said, we will have a recording available, and we'll send a follow-up email with a link to view that recording as well. So thank you so much to Michelle for joining me today, and also to all of you. We are really excited about Affinity+VE, and we're very happy to see all of the enthusiasm that we've been receiving from people. And we'd like to thank you all for attending today.